Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going through question number 5 from the June 2014 International A-Level Edexcel Mechanics M1 paper. And this question here is about vectors and vectors dealing with velocities and position vectors. And I'm specifically answering this question now for one of the students on the channel who left a comment asking about position vectors and velocity vectors and how they are linked, and he has some kind of confusions about them. So I'm going to be going through the question, as I said, to try to explain that in some kind of more detail so that the student will understand. Okay, so 5 part A is telling us, first of all, it says in this question, I and J are horizontal unit vectors due east and due north respectively. So it's like you're looking down on the page, okay, and I and J are due east and due north respectively. So I would be in this direction and J would be in that direction. You're looking down on a page that's horizontal on the table. This would be your I component, 1 unit in the X direction basically, and the J component is 1 unit in the Y direction. Okay, so that's I 1 unit in that direction and J 1 unit in that direction. That's what it means from a fixed origin O. And so it says position vectors, position vectors are given relative to the origin O. So when it says position vector, it means from O to that point is that vector. When it says a velocity vector like this first part, it's talking about the direction in which something is moving only, not relative to any particular origin. So it says a buoy B is running in a field with constant velocity 3I minus 2j meters per second. At time t equals 0, B is at the point with the position vector 10j meters. So basically what they're telling us here is that when time is 0, B is at the position vector 10j. So the position vector is what is given in relation to the origin. So say this is the origin. So it means when time equals 0, B is 10j. 10j is 10 units to the north. So this is where B is when time equals 0. That's telling us where B is at that particular time. And it is moving with constant velocity 3I minus 2j meters per second. So that means after 1 second, it's going to go 3I minus 2j. So it's going to go something like this. This will be the vector. This is where it's going to be after 2 seconds. After 1 second. Okay, because it's moving that. Every 1 second, it's going 3I minus 2j. 3I minus 2j. So that tells us the velocity of B. That's the velocity. That's like the direction and the speed with which it's going every second. All right. So that's how far it moves every second in that direction. After 2 seconds, it will be over here. After 3 seconds, it will be over here. After 4 seconds, it will be over here. It's moving in that straight line. Okay. So the position vector tells us where it is in relation to the origin. So when time equals 0, it's at this point. When time equals 1, it's at that point. When time equals 2, it's at that point. Okay, when time equals 3 is at that point, and so on. It's moving along this straight line. That's where it's moving. All right, so if you want to find its position after, for example, 1 second, then we've got to use this R equals R0 plus VT. R0 is the place it was when time was 0, which is this 10J, sorry. Okay, that's R0 here. That's where it was at 0 seconds. And then you got to add to that, okay, the velocity vector times the time, because if you want to find where it is after 1 second, you've got to go from O to where it was at the beginning, and then 1 velocity vector along. If time was 2, then you're going to go 2 velocity vectors along. If time is 3 velocity vectors along. It will tell you how to get from O to that point. You have to go from O to B and then B to that point. Okay, so the position vector tells us where it is in relation to the origin. Okay, and this tells us where it is when time is 0, and the velocity tells us about how it's moving. Okay, we'll go into more detail about that when we get to the questions dealing with it. But that's basically what that means there. All right, so now let's just answer the questions and we will get back to that eventually. It says we got to find the speed of B. Now B is moving. The speed, we know the speed is the magnitude of the velocity. It's the magnitude of the velocity. And the velocity of B is given by this vector 3i minus 2j. I like to write them as column vectors. 3i minus 2j. That's the velocity of b as a column vector. And we want to find the magnitude of the velocity of b. That will give us the speed of b, which is going to be the square root of 3 squared plus 2 squared. We don't have to worry about the minus sign. It's going to get squared anyway. That gives us the square root of 9 plus 3, which is 13. So the square root of 13, we could leave our answer like that, but it's better to write it 3SF because it's not an exact answer. So square root of 13 gives us 3.60555. 3.60555. Of course, we should give our answers to 3SF, so it's 3.61 meters per second. So there's the answer to part A, the speed of B. And part B says the direction in which B is running, giving your answer as a bearing. So we know the velocity of B, as we just were told, was 3 minus 2. Now we've got to think about the direction in which it's going. So let's say it starts from this point over here. All right, say that's the point where it's starting. We can see that it's going to go 3 units to the right for every 2 units it goes down, something like that. So it's going to go from here to there. That's like, if this is 3i, this is 3, this is minus 2. That's the direction that it's going in. So we got to write that as a bearing. Okay, so what we're going to do is I'm going to draw the north line here. The bearing is always measured from the north line. So if that's where it starts, there's the north line. We have to find the size of this angle over here. That is the bearing. From the north line, measured clockwise until you're going in the direction you want. This is the velocity of B. So we need to find this angle over here. Now this angle is made up of 2 parts. We could say one part is this 90 degrees. That's between north and east. And then you got this angle over here, which I'm going to call alpha. I'll call it alpha. So I can say that the tangent of the angle alpha is equal to opposite over adjacent. Now I don't need to write the minus 2 here. I'm just looking at the size of the angle. I'm not thinking about quadrants or anything right now. So I'm just thinking about the size of that's 2 units down there. So the size of the angle tan of the tangent of the angle alpha we're given by 2/3. So alpha is inverse tan of 2/3. We have to make sure our calculator is in degree mode. It's in radian mode right now. So shift, menu, angle unit, degree. Now it's in degree mode. So I'll say inverse tan of 2/3. And that gives us 33.690 degrees. That's 33.690 degrees. That's not the bearing though, that's just this angle over here. I need to add this to 90, so we can say the bearing of the velocity of B is equal to 90 degrees plus 33.690. So we just take this answer and we add 90 to it, and we end up with 123.690. Now bearings should always be given to the nearest whole number. So 124 degrees. Bearings would always be given to the nearest whole number, 3 figures, and it should be no decimal there unless otherwise stated. So that's the direction in which B is running as a bearing. Okay, so that's A and B. That doesn't really go into the issue that the student was asking me about, but the second part of this question does, part B. It tells, or part C, sorry, it says, at time t equals 0, a girl G is at the point with position vector 4i minus 2j meters. The girl is running with a constant velocity 5i plus 2j meters per second and meets B at the point P. Find the value of t where they meet. So this is the information from the first part of the question, which is about the boy running. And this is information about the girl running. And we've got to find the value of t when they meet and the position vector of the point where they meet. Now, so let's take into account this situation with the girl running. So the equation for writing the position vector is r equals r0 plus vt. So this tells us, this r here stands for the place or the position of the object at any particular time t. That tells you the position in relation to the origin, how to get from the origin to that point. R0 tells us what the position of that same object was when time was 0, and v is the velocity vector and t is the time after it started moving. right? So if this girl starts off at this position vector, so that means at time equals 0, her position in relation to the origin is 4i minus 2j. That does not tell us the direction in which she's going, it just tells us where she is, her position at time equals 0. So if this was the origin, for example, the girl would be 4i minus 2j. So 4i minus 2j would be somewhere over here. So I'll just draw it like this so we can... So it should be 4i minus 2j. Let's say that's 4i minus 2j. That's where she is when time equals 0. So that's the position vector of the girl when time equals 0. So you could say that that is the vector r0. That is a vector from r to 0. Let me just make that a bit thinner. So this is the vector from r to 0. This is a vector r0. Sorry, this is r0 for the girl. This is where she is when time equals 0. If you put time equals 0 there, that's where she's going to be. Now, her velocity vector is 5/3 I plus 2j. So this is r0 is 4i minus 2j. Okay, and her velocity vector, the velocity vector of the girl, is 5/3 I and 2j. So that means from this point, she's going to be moving every second 5/3 to the right and 2 up. So it's going to be like 5/3 is just like less than 2. So it's going to be from here, she's going to go 5/3 and 2 up. So 5/3 and then 2 up, something like that. It's going to be actually, it's going to be shorter than that, isn't it? You don't have to put it to scale. I'm just trying to make it a bit realistic so we can see. So that means now this vector here that I'm going to draw is actually the vector which tells us about how she's moving. She's moving along this there. That's where she was at time equals 0. That's where she's going to be at time equals 1. And she's going to continue going. Right? She's going to continue going along these same things. So if I just copy that, she'll continue going along that same route. That's where she'll be at time equals 2. And you can continue time equals 3, time equals 4, time equals 5, and so on. She'll continue going like that. So that tells you what her position will be at those certain times. And so on. All right. Now, so how do we write this as a equation? We can say the position vector of the girl is equal to r0, which is 4 minus 2. That's where she was when time is 0. That was r0. Plus v, which is 5/3 2 times t, which is the time, okay, in seconds. So that will tell us where she is in relation to the origin. So if I want to find where she is in relation to the origin, it means the position vector of the girl when time equals 2. I put 2 in this equation, and that will give me the vector from O to that point. That will give me the vector from O to that point over there. That will be basically her position vector after 2 seconds. And it will be what I find when I put 2 in here. So that's like an example of how that works. Okay, so now we want to deal with the boy's situation. Now the boy is running in the field, and his velocity is 3i minus 2j. And as we said, at time equals 0, his position is 10j. So it's going to be like up here somewhere. So I mean, I haven't really left enough space, but it's going to be up here somewhere. I mean, we don't normally have to draw these. I'm just drawing this to give you an idea. So like, let's say 10j is somewhere up here. Okay, that's 10j. So this is his position vector. Okay, this is r0 for the boy, 10j. Okay, that's where the boy was when time equals 0. And he's moving with the vector he's moving with the vector 3i minus 2j. So 3i minus 2j. So his movement is kind of like 3i and minus 2j. So it's a bit more steeper this way. Okay, 3i minus 2j, a bit steeper than that one. And he's going to be going something like this. Let's make this a bit more realistic. All right. So now he's going to be going along this line over here, say. All right. So eventually they're going to meet. Eventually there's going to be a point at which they meet, as we can see here. Eventually their paths will cross. We got to find what the time is where they meet and what the position vector of that point is. So if we find the time where they meet, it's very easy to find the position vector. So now let's write down for the boy his position vector. His position vector is going to be given by his position when time was 0, which is 10j, which means 0, 10. That's 0i plus 10j, plus his velocity vector, which is 3i minus 2j. So 3 minus 2. 3 and minus 2. Okay. So therefore, we know the position vector of the girl, as we just wrote down there, was 4 minus 2 plus 5/3, 2 and t. Okay, so where they meet, okay, is when they have the same position. They'll meet when they're in the same place, when the position vectors are equal. So this is the position vector of the boy and this is the position vector of the girl. They're going to meet when these two are the same, because how you get from O to that point will be the same for the boy and the girl. They will be in the same place at the same time. So how do you find when they're in the same place? Well, we can equate these together. This is times t. So this is going to be, if we just write this is 3t and this is 10 minus 2t. That represents the position vector of the boy, and that's equal to 4 plus 5/3 t and minus 2 plus 2t. Okay, when these two are the same, then they will meet. So now we can just make two equations and see if they give us the same value of t. So I can make one equation from the top, 3t equals 4 plus 5/3 t. And I can make one equation from the bottom part, which is 10 minus 2t equals minus 2 plus 2t. So that we've equated the I components and the j components. And if they both give us the same value of t, it means they definitely will meet at the same time. So if I solve this equation, it looks a bit easy to solve. You've got 10 plus 2, which is 12, equals 2t plus 2t, which is 4t. So t is equal to 3. So they meet after 3 seconds according to the I components. According to the j components, let's multiply by 3 to make it easier, not dealing with fractions. We'll have 9t equals 12 plus 5t. So 9t minus 5t is 4t equals 12. Again, t equals 3 seconds. So we can say for sure they meet. They meet at t equals 3 seconds. Okay, and it tells us then that's part 1. Find the value of t when they meet. And to find the position vector of p, we can actually put t equals 3 into any of those two equations. I think the one for the boy is easier to deal with, which is 2 minus, it's 10 minus, it's this one here, 3t and 10 minus 2t. So we know that the position vector of the boy is given by, as you can see, it's 3t and 10 minus 2t. So that's going to give you 3 times 3, which is 9. And 10 minus 2 times 3, that's going to be 9. And that's 10 minus 6, which is 4. So 9, 4. So we can say they meet. So that you can say the position vector of P is going to be 9i plus 4j. And we can check our answer by substituting those same values into this. So you have 4 plus 5 over 3 times 3 and minus 2 plus 2 times 3. That's going to give you 4 plus 5, which is 9, and minus 2 plus 6, which is 4. Gives you the same answer, so we know we're correct. Just a little check. So we know the position vector of P is 9i plus 4j. Okay, so there we have the answer to part 5, part C. So I hope it made it a bit clearer how the velocity vector and the position vector of an object are related. The velocity position vector tells you the point at the place where the object is at a certain time. Okay, it doesn't tell us the direction it's moving in. And the velocity vector tells us in which direction it's moving. So to get the position vector, you need both the position vector at time equals 0 plus the velocity vector times the time, and that will tell you where it is at any particular time that you need. Okay, so I hope that made that clear to you. If there are any other questions, you can ask me on the comments, no problem. Thank you for watching. Other questions about vectors from M1 can be found in the playlist over here. Other questions from this particular paper, June 2014 International A-Level M1 exam, can be found in the playlist that will appear in this region. You can subscribe to my channel by clicking on this link. Thank you for watching. See you soon.